Hi everyone and welcome. I am so glad you're joining me for today's lesson. We are going to explore a very interesting factoring technique called factoring the sum and difference of cubes. Now that we have learned the remainder theorem and the factor theorem, we have powerful tools for factoring polynomial functions of degree 3 and higher. And today we'll look at another special type of polynomial, one that can be factored by using special algebraic identities. So more specifically, we'll learn how to recognize and factor expressions that are sum or difference of two perfect cubes. By the end of this lesson, you'll be able to factor the sum and difference of cubes using an appropriate factoring formula. And the formulas that we'll be using are the following. A plus b to the power 3 is a plus b, a squared minus ab plus b squared. And the way that I like to remember this is, first of all, the terms have to be perfect cubes. Remember that perfect cubes come from something to the power of 3. We'll explain this in more detail in the examples. And when I factor this, I check the sign in between, and the first factor will be exactly what you see here, but without the powers. If you have a cube plus b cube, a plus b is the first factor. Now the second factor, if you look at it, it looks familiar, and it's probably bringing back to your memory the perfect square trinomial. But remember, this is not a perfect square trinomial. Perfect square trinomial would also have a coefficient 2. That's what is missing in here. And it doesn't have a coefficient 2. So if it did have a coefficient 2, it would have been factored further. So the way that I wanted to remember is, oh, this other factor is like perfect square trinomial, but without the coefficient 2 in the middle. Difference of cubes works in the same way, but here you will have a minus b as the first factor, so without the powers. And the other factor will look like a perfect square trinomial, and all the terms here will be positive. Now, if you're wondering, so how do I figure out all these signs, then I would say that if you look at both of them, there is only one negative sign. So when you have a cube minus b cube, the negative sign will be in the first factor, the rest will be positive. And in a cube plus b cube, the negative sign will come right after the first. And we need that negative because that's how all these terms in between simplify, and we end up with just a cube and b cube terms in the expanded form. So let's start with our first example. So we have x cubed minus 8. So I see two terms. I see a very obvious here power of 3. So I'm going to check and see if this term is a power 3 term as well, or a perfect cube. So I'm thinking, if I want this to be to the power 3, what number can I put here in the base? It looks like 2 to the power 3, that's an easy example, obviously. And the first term, as you can see, is already to the power of 3. So it shows the powers without having to change anything there. And then we have the minus sign in between. So I'm going to I'm going to write the factored form of it. So I will say there will be two factors. One is binomial, one is trinomial. So the first factor will be the one without the power. So in our case, x minus 2. Now the other factor will be a trinomial that looks like that perfect square. So x squared, 2 squared. And in the middle, you will have just the product of 2 and x, not double of it, just the product of 2 and x. And obviously you want to write it in a better shape, x minus 2, x squared plus 2x plus 4, and this would be the factored form. If you're wondering whether or not it's necessary to show this step, I would say no. But it's up to you. Sometimes we like to see where the numbers come from, and it gives us more confidence in the process that we're following. Next, we're looking at 27x cubed plus 125. So again, I have two terms in here. So since I have two terms, I look for cubic powers in here, because I do see a power of 3 in x, but it has also a coefficient here. So if I have power 3, so I can put 3x in here. 125, I can bring 5 in here, and then to the power of 3. So as you can see, we have the difference of cubes, and the value of a is 3x, the value of b is 5. So we can start factoring. So we have 3x minus 5 as our first factor, and the other factor would be 3x to the power of 2. The last term is 5 to the power of 2, and then the middle term will be simply the product of 3x and 5. Don't multiply by 2, just 3x and 5. Obviously, I'm showing the steps in here because I'm explaining it, but you can write this in one step because you are very skilled in simplifying expressions a lot faster than I'm pretending here. So 9x squared plus 15x plus 25. And this would be the completely factored form of it. Next, we have x to the power 9 minus 512. So things are getting more and more interesting. I see a power of 9. I never factored a power of 9, but I know that 9 is a multiple of 3. So I will try to write x to the power 9 as a power of 3. And I'm thinking the term that I have to put in the base here will be x cubed. Remember, the power law multiplies the powers. And then we have to minus in here. I'm going to try to find a number that I can put on the base to get 5/12. So this is fairly easy. You can find the third root of 5/12 in the calculator, or you can find 512 to the power of 1 over 3. It's the same thing, and I get number 8 in here. So I'll say that I'm ready to start factoring as the difference of cube, x cubed minus 8. And the other factor will be x cubed squared. The last term will be 8 squared, and the middle would be 8 times x cubed. And we're going to continue a little bit further because we want to write this in a neater form. But not only that, notice how here we have another difference of cubes hiding, and we have x cubed, obviously, which is a perfect power of 3, but number 8 also is a perfect power with base 2, a perfect power of 3. So we are going to continue factoring that as well. Let me make it actually a different color, so I don't know, it helps. And we have x minus 2, x squared plus 2x plus 4. And obviously, we're going to write this other factor that we had in here in a cleaner format. So x6, 8x to the power of 3, and then plus 64. Don't you dare factor this any further. It doesn't factor because otherwise the formula wouldn't have been what it is. Now, let's continue with another example. So this time we have powers of 4, and we're thinking, we don't know how to factor powers of 4. We can only deal with powers of 3 or multiples of 3. But continue looking at the next term. You see that you have x, so x can come out. Then the next thought is, but wait a second, 7 is not a perfect cube number. Well, check and see if you can take it out as a common factor. So 448 divided by 7, thank goodness, is a factor of both, a common factor. So we have x cubed minus 64 in here. And from here on, we're going to rewrite this as power of 3 and this as a power of 3. So this is going to be x to the power of 3, and this is 4 to the power of 3. So we have 7x, and then x minus 4. Oops, I meant to use the laser here. So x minus 4, and then x squared plus 4x plus 16. And in this case, we got 3 factors for this very simple expression. Now, we'll continue with another example. Example 5. Again, we don't see powers of 3, but as long as we see powers that are multiples of 3, we're good to go. And the way we want to think is bring the powers, or write brackets with powers of 3 out, and then think, okay, what numbers do I have to put in here to reproduce what I had? So A6 means that we need an A square here, and for B12 means that we need a B4 in here. And for 729, we're going to check and see if 729 is a perfect cube. So we're going to cube root that. And we get that it is actually. So we have 9 to the power 3, which is 729. And for C, we're going to bring a power to power of 4. So 4 times 3, 12. So we got our A's and our B's in here. So we're ready to factor using the difference of cubes. And we have A squared B4 minus 9C4. That would be our first factor. And the second factor will be A squared B4 squared. The last term in here is 9C4 squared. And the middle term will be the product of A squared B4 with 9C4. So we're going to write this a little bit more neatly, because why not? Remember, we have A squared to the power of 2, A4, B to the power of 8. Coefficient has to come first, so we have 9, A squared, B4, C4. And lastly, we have, don't forget this, 9 squared, 81. C to the power 4 squared is C power 8. We're done with this factor. It's not factorable any further, so we're going to leave it the way it is. We do have a little bit of work in here. So as you can see, we have powers that are even, and even powers make us think of of difference of squares. So remember that the difference of squares formula, a squared minus b squared, suggests that the factored form of a squared minus b squared equals a plus b, a minus b. Now, since we're talking about it, just for comparison, only difference of squares is factorable. The sum is not. With cubes, it works out that both sum of cubes and difference of cubes are factorable. Now, let's finish this up. So we are going to first identify what we have squared here in each term. All right. And for the first one, a squared b4, that means that we have ab squared. So remember, a squared b4. 9c4, we have 3c squared. So 3 squared is 9. C squared to power 2 is C4. So this is what we are trying to factor here. So we're going to say that's AB squared minus 3C squared times AB squared plus 3C squared. So remember, it is A plus B, A minus B. And then obviously we have the other factor here, A4, B8. Plus 9a squared b4 c4 plus 81 c8. Fun, isn't it? And we're moving on now to the next example. So we are trying to do a variety of examples, each of them bringing something new, and here go fractions. So you see, this time we have the sign plus finally, because I just noticed that in every question we had the difference of cubes. So I'm happy to see this now. We're going to write each term as power of 3. I'm happy to see that the power I see here is a multiple of 3. This is multiple of 3, so that can happen then. So we can write x6 as x power 2 to power 3. And we're going to write 1/8 of y24, so y will be 24 divided by 3, that's 8, and 1/8 will be equal to 1/2. Remember that 1/2 to the power 3 is 1/8. And now we'll factor. So remember, the first factor is x squared plus 1/2 of y to the power of 8. So whatever you see without these powers. The other factor will have 3 terms. So it will have x squared squared. So this thing in here squared. This thing squared at the end. So 1/2 y8 squared. And in the middle, we'll have that minus or the negative term. And that will be made of the product x squared and 1/2 of y8. And we're going to write this in a slightly more simplified form, so we want to write this in a neater form. Remember that the sum of squares is not factorable, and this is not a perfect square number regardless, so nothing changes for the first factor. And the other one will be x to the power 4, remember, 2 times 2. And then minus, I'm going to make this minus red until I remember very well where the minus is when you have the sum of the cubes. And now we have coefficient 1/2 x squared y8. And then we have 1/2 to the power 2 y8 power 2. That's going to be 1/4 y to the power of 16. And voila, this would be the factored form of this sum of cubes. Now you have quite a few questions that you may want to practice, and I'm going to scroll down slowly here so that you can see them and you can practice on your own. So grab your notebook, write the questions, obviously stop the video, write the questions, and practice. The more practice, the faster you become at thinking. The faster you work, the more you force your brain to think also faster. So, and it definitely sharpens your focus as well. And here's the answer key. And as always, thank you for learning with me, and I really appreciate your presence. And I hope you find these lessons and instructions useful. And I hope they inspire you to learn math and see how beautiful math can be and how beautiful it is actually. Bye for now, and thank you for learning with me.